Okay, so we're going to have a look at another question from the 2022 HSC Standard 2 Maths paper. So here we're told the diagram shows an aeroplane that was flying towards an airport at A on a bearing of 135 degrees. When it was at point 0, 20 kilometers away from airport at A, the flight course was changed. The aeroplane landed at an airport at B directly south of point O. The distance from O to B was 50 kilometers. Show the distance between airport A and airport B is 38.5 kilometers to one decimal place. All right. So for part A, we're going to draw a little diagram. This is essentially a big triangle. We were told the bearing is 135. That means this angle up here is 135 collectively. Now that means the uppermost angle of the triangle is going to be 45, because 45 plus 135 is 180. If this is 45, this is also 45. So this is a convenient piece of information straight away. We know that this length here is 20, and this length here is 50. We've been asked to show that AB is 38.5. Let's call this X. Well, we can actually do this straight away using cosine rule. So we know that x squared is going to be equal to 20 squared plus 50 squared minus 2 times 20 times 50 times cosine of the angle between 20 and 50, cosine 45. So if we plug this all into our calculator, we will find that x squared ends up being equal to 1485.78 ... and now we need to take the square root of this. So this tells us that x, which happens to be the distance between A and B, this being A and this being B, is the square root of 1485.78. That is 38.54 ... So this is 38.5, correct to one decimal place, and that's in kilometers. So this is the first part of this question. Now in part B, it says use the sine rule to find angle OBA. So this is the angle formed when we start at O, move to B, and then move to A. So we start at O, move to B, move to A. So we've got to use sine rule to show that this angle down here, which we'll call theta, well, we haven't been told what it is. We have to use sine rule to just find it. So this x value here we've now found is about 38.5. So we have an angle side pair here and here. We have an angle side pair here and here with only one missing value. So we can use sine rule with these two pairs of values. So we get sine theta on 20 is equal to sine 45 on 38.5. This implies that sine theta, we multiply both sides by 20. Sine theta is 20 times sine 45 over 38.5. If we apply the arc sine, this tells us theta is equal to the arc sine of 20 times sine of 45, all divided by 38.5. So therefore, theta, and we need to be careful to round to the nearest degree because the question does specify this, is in our calculator shift sine of 20 times sine 45 divided by 38.5. That gives me 21.5509, 21.5509 ... So it does say nearest degree, so we'll press our degrees, minutes, seconds button on the calculator. 21 degrees, 33 minutes. 33 minutes is more than 30, so it rounds up. So this is going to be 22 degrees to the nearest degree. And we can also see that from the 21.55, 55 is closer to 100 than it is to 0, so this would round up either way. So this is part B. Now for part C, they ask us what is the bearing of the airport at B from the airport at A. So be really careful with this wording. Let's go back to our diagram. We're asked for the bearing of the airport at B from A. So we draw a little compass at A. We're being asked what is this angle? What is the angle clockwise from north, centered at point A, that gets you a vector that points towards B? Well, we can use some geometry here to find this. We know that this angle here is equal to this angle here, because this is a Z angle. So just based on our simple geometric principles of Z angles, we know these are equal. We just found that theta was 22. So this means for part C, the bearing in question is 180 degrees, the flat angle on the right-hand side, plus the 22 degrees that we just calculated. It's 202 degrees, and this is correct to the nearest degree. This is under the assumption that 22 degrees was rounded to the nearest degree. So this assumption carries through. And so this is the answer to part C. So now let's take a look at the marking. The marking for this question, because of the way the question's split up, the marking is fairly straightforward. If you attempt to use the cosine rule or some equivalent merit in part A, you will get 1 mark. For the second mark, you have to have 38.5 to 1 decimal place with correct working. For part B, you will get 1 mark for attempting to use the sine rule, but not quite getting the right answer. For the second mark, you will need to have attempted to use the sine rule and gotten the solution. And then for part C, because it's just 1 mark, you have to have 202 degrees. So this is how we do question 33 from this paper.